Hello. Good morning, everyone. One sec. Let me just check if I'm clearly visible and audible to you all. Okay. Sorry for the delay. One sec. Yep. Okay, so now that I am clearly visible and audible, if I'm clearly audible to you all, can you give a thumbs up, please? Good morning Joe, good morning Nalin. I am good. Good morning Venkatesh. I am good Nalin, how are you? Okay, so everything is fine, I think. Yes, it's completely audible, completely visible. Okay, thank you Joe, thank you Nalin. Okay, so let's start, shall we? You're already running 10 minutes late. Okay, so as you can see, good, yes, obviously. How is your preparation going? Okay, how's your preparation going? Okay, so my dear students, okay, so today what we will be studying amines and biomolecules. So basically we'll be doing the most repeated PYQs of amines and biomolecules. Okay, clear? Okay. How much, on a scale of 1 to 10, how much scared of this topic are you? Or you're confident, or are we talking about, okay, how much scared actually? Because biomolecules part is a little related to biology. If you are not opting for biology, that might get a little tricky for you. Okay, so on a scale of 1 to 10, how good or how bad are you in amines and biomolecules? Okay, so 50-50, 50-50, 0 out of 10, no, don't say 0 out of 10. In biomolecules are just factual. Some things you can just remember facts wise. 7 Venkatesh, good. So Joe, 50-50, okay, so we'll try to do it 100% today. And Nalin, obviously for you, we'll start from 0 to 10, we'll go there. Biomolecules is boring, I know, because it's related to biology, but what you can do actually, there are some things which are related to chemistry, amino acids, proteins, nucleotides, right? So something are factual, actually all things are factual there. It's just hormones in our body, carbohydrates, proteins, little bit terms here and there. Yeah, I know. Hi Lou. Okay, so it's okay, you will get through me. Okay, I know biomolecules is a little bit boring even for me. Yeah, because it's completely factual, no calculation, no reactions, nothing. You just need to remember everything. Okay, so let's start. Okay, so firstly we'll be doing question of amines, then we'll be moving to biomolecules. Okay, hi Darshan, hi Renuka, good morning everyone. Okay, so first question, a secondary amine is, what is a secondary amine? Hi Kumar, hi Jasani. Okay, so the first question, a secondary amine is, so we know amine is when you have, one second, okay, when you have, what is this? This is ammonia. This is ammonia. If you replace one hydrogen with a carbon, this becomes a primary amine. Okay, and if you replace two hydrogens with carbon, it becomes a secondary amine. So what should be the correct answer? And guys, sorry, today poll will not be there as in the last class. There's some technical issue going on. Okay, so yes, you answer like that, I'll check your answers here only. Okay, D, how D? Are you guys even reading the question yet? A secondary amine is, this is a secondary amine, right, where two hydrogens are replaced by, two hydrogens of ammonia are replaced by two carbons or organic groups, you can say. Due to carbons, due to 2 carbons. So let's see, compound with an NH2 group on the carbon atom in a number 2 position. Nope, that is if NH2 is there, that means only one hydrogen is replaced. That means we are talking about primary amine here. A compound with in which 2 of the hydrogens of NH3 have been replaced by an organic group. So that is a secondary amine. That is a secondary amine we are talking about, where 2 hydrogens of this ammonia is replaced by an organic group. An organic compound with 2 NH2 groups, that is a diamine. Okay, again, when 2 hydrogens are there, it is a primary amine, and when 2 NH2 groups are there, that is a diamine. The compound is a diamine. Okay, a compound with 2 carbon atoms and an NH2 group. Again, NH2, that means only one hydrogen is replaced by a carbon. One hydrogen is replaced by a carbon. It is a primary amine. It is a primary amine, not a secondary amine. One second. Okay. So yes, correct answer is B. B. Pavitra answered B. Tanishka answered B. Joe answered B. Okay. Venkatesh B. Jayasani B. Yashash. Pavitra B. Again. Okay. Yes. Sharanu B. Firstly, you all were answering D. Now you are answering B. I think you understood it, right? Okay. That's actually nice. Okay. B is the correct answer. Okay. Only PYQs. Hi Dikshita. Dikshit, I think. I'm only PYQs enough. Actually, depends on how much PYQs you are doing, plus conceptual clarity should be there, because only PYQs, yes, they are a blueprint of KCET, but that doesn't mean those questions will get repeated. So PYQs plus your concepts should be crystal clear. Only then you will be able to answer all kind of questions, because PYQs may get repeated, might not get repeated. Okay. Rank, I have no idea, Kani. I think Jasmine ma'am have covered a video about, and no one can predict the rank actually. So Jasmine ma'am have made a video about that. If any doubt you have how to get an idea, okay, you can watch that video. 15 days enough for getting rank under 2.5k in KCET. So if you are determined, Samarth, firstly it seems a little impossible, right? 15 days. But if you have the conceptual clarity, if you know PU1, PU2 syllabus clearly, it's on the tips of your fingers, okay? And you can solve all the PYQs that you like last 10 years, 20 years, whatever you're referring to. If you can solve all the PYQs, then obviously you can, okay? If you have the conceptual clarity, if you are well versed, if you can finish those 60 questions in 60 minutes, then yes, you can score it, okay? But if you are starting from zero ground level, then that might be a little, little impossible, yeah. Okay. So yes, B, Renuka also answered B. If anyone, I think if you get 180 out of 180, then your rank might be like that. I think that would be 1, no? That's like, I don't know if you can get that rank actually. You can't get a 180 out of 180 actually. I think, okay. But if you do get Kani, okay, Kani, if you do get 180 out of 180, I will give you a gift from myself, okay? My side will get a gift, okay? Good morning, Nagraj. Okay, so the answer is option B, because a secondary amine is an amine in which 2 of the hydrogens are replaced by organic groups, or you can say carbon, okay? Organic group means carbon. Okay, hi Sagar. Hello everyone. How is your morning going? Okay, so which of the following reaction does not yield an amine? Does not yield an amine. I'll write here. The first reaction is an alkyl halide when treated with ammonia. When treated with ammonia, that is your first reaction. You need to tell me the reaction which does not give amine. Okay. Second reaction is nitrile. Okay. When treated with H2 nickel in presence of sodium amalgam and solvent is ethanol, C2H5OH. Third reaction is again nitrile, and we are doing hydrolysis of nitrile. Then last one is amide. Okay. And reduction, we are doing what? We are doing the reduction of amide. Okay, LiAlH4 and then hydrolysis. First step is LiAlH4 and second step is hydrolysis. Okay, tell me which of these reaction will not give amine? Which of these reaction will not give amine? B Tanishka, B Nalin, B Kani. Okay, no worries my dear kids, but it's okay, it's okay. So actually there are 6 methods of preparation of amines. Okay, so we have ammonolysis, we have Hofmann bromamide degradation. Okay, we have reduction of nitro compounds, reduction of nitrile, and then we have Gabriel phthalimide, that is also one. And the 6th one will be your amide, reduction of amides. Yes, reduction of amides. So that is 6, right? So here let's see, this is ammonolysis, Hofmann ammonolysis of alkyl halides. So firstly we'll get a primary amine, then secondary amine, then tertiary amine, and then quaternary ammonium salt. Okay, so any of you answered B, that is wrong option. You are not studied, you have not studied amines properly. So in this case, yes, we will get amine. In this case, when we are doing reduction of nitrile compounds with H2 nickel in sodium amalgam and ethanol, okay, or we can use if this reagent is given, or LiAlH4. Lithium aluminum hydride is present. In both of these cases, yes, we will get an amine. Okay, now third reaction, again, this is hydrolysis. This reagent gives hydrolysis, and when you do hydrolysis of nitrile compound, you get 2 products. Firstly, if you do partial hydrolysis, if only small amount is present, so firstly we will get amide. Right? Amide. And if you do further hydrolysis, if you do complete hydrolysis of amide, what we will get? We will get carboxylic acid. No ammonia, sorry, no amine is there. No amine. What are we getting? We are getting carboxylic acid, and in between we'll get amide. Okay, not amine. Okay, now this one, what is this? RCO NH2. If we do reduction of amide, in LiAlH4, this is a very strong reducing agent. Lithium aluminum hydride is a very strong reducing agent. What it will do? It will reduce this amide to amine. RCH2 NH2. Clear? Okay. So good morning BBC. Yes, so the correct answer is, okay, it is shifted a little bit, I think. Okay. Yes, so the correct answer is option B. Sorry, B is the B. Yes. Yes, that means only this option is incorrect. Because this will not give an ammonia. This will not give an amine actually. Okay, sorry. Some are answering C. So no. The correct answer is B. Only third. This will not give amine. Okay. My bad. I actually thought the answer are like this only. A, B, C, D. Sorry. Okay. Then you answered correctly. B does not give amine. Yes, B does not give amine. This B does not give amine. Correct, Pavitra. Sharanu, Mohammed, Dikshita, Sagar, Maya. So I think you are answering like me. C, you're thinking this is C, but this is option B, only third. This is option B. Okay? No worries. Okay. The options are little bit hidden. I hope not for the other ones. Okay. The method by which aniline cannot be prepared. By which method you cannot prepare aniline? By which method? First is nitration of benzene, followed by reduction with tin and concentrated HCl. Nitration of benzene. When you do nitration of benzene, what we will get? This NO2, right? This is the product after nitration of benzene. And if we reduce in presence of tin and HCl, concentrated HCl, yes, we will get aniline. What we will get? We will get aniline, right? That is aniline. Okay. Kani answered C. Cannot, the answer is cannot. Okay, like focus on this word, which is from which method aniline cannot be prepared. So from first method we can prepare aniline, so yes. Second, degradation of benzamide with bromine in alkaline solution. What is this reaction? Hofmann bromamide degradation. This is Hofmann bromamide degradation. And what reagent we are given here? Just see. So we have benzamide. This is benzamide. Okay. If we treat benzamide with bromine in alkali solution, with Br2 in alkali solution, let's say sodium hydroxide, what will happen? This carbon will get removed, right? Whenever you are doing Hofmann bromamide degradation, the product will have one carbon less than your reactant. The product will have one carbon less than your reactant. Okay, so we'll get here this compound, aniline. We will get aniline. That means it is also a correct way of synthesizing aniline. Okay. Third option, reduction of nitrobenzene with H2 hydrogen in palladium. That is also similar to this one. This is also a reducing agent here. Okay. So yes, this is also a correct way to synthesize aniline. Now look at the last one. Potassium salt of thalliumide treated with chlorobenzene. Chlorobenzene, potassium salt of thalliumide. What is potassium salt of thalliumide? This is potassium salt of thalliumide. This is potassium salt of thalliumide. If you treat it with chlorobenzene, okay, followed by hydrolysis will give us aniline. Will it? Do you think will it give us aniline? Do you think? D. So all of you answering correctly. The thing is, this chlorobenzene, whenever we are treating this thalliumide, potassium salt of thalliumide with an alkyl halide normally, okay, this involves the breaking of this bond. Okay, when this bond breaks, this thalliumide ion will attack here. Right, on this carbon, and the product formation will happen. Okay, we'll get an amine. But the thing is, this bond is not easy to break. Why? Because of resonance, this bond has a double bond character. Because of resonance, this bond has a double bond character. Okay, it has a double bond character. Now, if it has a double bond character, will it be easy to break? No, it won't be easy to break. You can't break this bond. Okay, so that means the reaction will not happen. If you add this and try to react them, the reaction will not happen. No reaction. So that means option D is your correct answer. Yes, and all of you, they are Gabriel thalliumide synthesis. Hey, what do we use Gabriel thalliumide synthesis for? What kind of amines we can synthesize from Gabriel thalliumide synthesis? What kind of amines we can synthesize from Gabriel thalliumide synthesis method? Okay, what kind of? As in, yes, it gives primary amine, only primary amines. Okay, you can only synthesize primary amines. You see, you can't synthesize these, what do you call it? This will be aniline, right? That is aromatic amines. You can't synthesize aromatic amines here. Why? Because obviously, as long as it's the bond breaking is very difficult here. Double bond character ki wajah se. Okay. Is it only Gabriel thalliumide? No. If they give different reagent, then obviously you can predict that this reaction will not happen. For example, in the last question, I think, yes, in here they give, if this kind of group is there, CN, and then they are doing hydrolysis, in that case also you will get an amide, not an amine. Okay, so it depends on what kind of reagents we are given. Here we know that this won't happen. Why? Because we are breaking this bond, and breaking of this bond is not easy. It's not feasible at all because it's a double bond. Okay, no, it's not only that method. Okay, but from Gabriel thalliumide you can't synthesize aniline. Yeah, that you can say. From Gabriel thalliumide you can't synthesize aniline because aniline is a aromatic amine. Okay, primary amines. Correct, Joe. Correct, Shravya. सागर करेक्ट क्लियर. फास्ट कहाँ जाना है फास्ट. सो कौन सा ट्रेन पकड़ना है. ओके गैब्रियल थैलेमाइट नो इट वोंट. ओके डी लू अनंत डी. Okay, so all of you answered D. That's very good actually. How many questions from amines for KCET? So amines come in the high weightage category, so you can expect questions from 3 to 5 questions. You can expect actually 3 to 5 questions. Okay, that's a high weightage topic. Yeah, that is, yep. Pakdo, good. You have a train to catch, I think. Okay, next question. Okay, the question is, which of the following has the lowest boiling point? So whenever we talk about boiling point, what do we talk about? Whenever we talk about boiling point, what we are exactly dealing with? We are dealing with intermolecular forces. If the intermolecular force is strong, if the intermolecular force is strong, the boiling point will be high. Because you will need much higher energy to break the intermolecular forces. To break the intermolecular forces, you need higher energy. That's why higher boiling point. So among these, whichever have the lowest intermolecular forces, that will be having the lowest boiling point. Lowest intermolecular forces equals to lowest boiling point. Okay, so what we are looking for here, lowest intermolecular forces, lowest as in least strong. Intermolecular forces, right? Now what forces are existing in these? Second option, B, C, D. Okay, all variety of answers are there. 1 second. C, D. Okay, so let's start with here. What kind of intermolecular forces are in A? It has hydrogen bonding. This is an amine, primary amine. It has hydrogen bonding. Okay, this is an ether. In ether there is no hydrogen bonding. What do it have? It have dipole interactions. It has dipole interactions. Methanoic acid have hydrogen bonding. And this is alcohol. Again, in alcohol also we have hydrogen bonding. Which among the following is the weakest? Weakest is dipole interactions. Yes. So the correct answer is B. Weakest interactions, dipole interaction, lowest boiling point. Okay? Yeah, it's okay, Joe. Yeah. There is a character in a famous series his name is also Joe, right? So whenever I call your name, I remember of him. Anyways, okay, so C, D, T, B, D, C, no. Pavitra answered correctly. Yes, Sunny, Kani, D. No, Mohammed, the answer is not D. What about options? Okay, B, Kani, B. Okay, Praveen also answered B. Okay, so I think we have a majority of B here. Okay, next question. Which of the following is least soluble in water? Solubility. When we talk about solubility, again, what are we looking for? The least hydrophobic portion. Let's say if we're talking about alcohol, we're not talking about alcohol here, but here this part will determine whether this alcohol will be soluble in water or not. Because this part is water insoluble. And larger this part is, least soluble that alcohol will be. Now this reason applies to everywhere. If we are talking about amine also, if this part is large, the solubility will be less, least soluble in water. In water, the solubility will be least. Okay, so here we have a primary amine, this is a primary amine, this is a tertiary amine, this is a secondary amine, this is a primary amine, but which among the following has the highest hydrophobic part, highest alkyl group, highest R group actually, which has the highest R group, biggest R group, biggest R group. So the biggest R group, okay, again you guys have lots of doubt. Yes, I know this is CH3 and 3CH3 group attached is very bulky. Yes, it is very bulky, but look here. We have this whole ring, it has around 6 carbons, right? It has 6 carbon. This ring is really big. One more thing, in between aliphatic amines and aromatic amines, aliphatic amines are soluble. Aliphatic amines are generally soluble in water. Aliphatic amines are more soluble in water. Then aromatic amines. Why? Because yes, it is aliphatic, it is maybe secondary, maybe tertiary, but the group is not that big. As compared to the aromatic amines. This big group that is actually very big. On a scale, if you see, methyl will be this much and your benzene will be this much. Okay. So yes, good morning, Neer Zafar. Okay, D. Yes, so yes, everyone now is answering D. Correct. So the correct answer is option D. Option D. Which of the following is the least soluble? That will be your aniline. D, B, you were confused, Nalin? Okay, so Nalin answered D, Sudhir answered D, Anant, Shravya, Sunny, Pavitra also D. I hate this chapter. Don't hate it. Like, just solve the questions solve the question along me, along with all of us actually. You won't hate it, okay? This one is actually a little logical. There is a logic here. You can predict it, that we are talking about hydrophobic part, which have the largest hydrophobic part, they will be the least soluble. Boiling point, intermolecular forces, weak intermolecular forces, lowest boiling point, right? So we have still some logic lying around here, some chemistry we can do here, okay? So don't be like that. Why not B? Because in comparison to methyl and this phenyl, phenyl group is much larger in size as compared to these 3 methyl groups. Phenyl group is much larger in size compared to these 3 methyl groups. Okay, or one thing you can say, we have 1, 2, 3 carbons here, and here we have 6 carbons, right? 6 carbons. Structure wise, it's also very big, and larger the hydrophobic part, least soluble will that compound be. Larger the hydrophobic part, least soluble that compound will be. Good morning, Anand. Okay, so I hope your doubt is clear. Shravya, next question. So you have a sequence here. If you can see, the sequence goes like this. CH3 CH2 Br, which is an alkyl halide. It is treated with KCN. What should be the correct sequence, you can tell me? Okay, yes. So when it is treated with KCN, it is CH3CH2Br, an alkyl halide. With KCN, it will undergo nucleophilic substitution reaction. Okay, I'm not writing the product yet. I'm looking for your answer. So what is your answer? Okay, A. Okay, so we will get a compound A. And then when that compound A is treated with lithium aluminum hydride, we get compound B. And when that B compound is treated with nitrous acid at around 0 degrees Celsius, we will get C. Okay, now C. When this compound A, D, hi Hamshika, A or D. So some of you are answering A and some of you are answering D. C, yes, so we have A, we have D, we have C. Okay, let me see which is the correct answer. So first. Okay, so Yes, no. D is not the correct answer. Look clearly, look carefully, okay? Okay, now let's see. When alkyl halide is treated with KCN, it will undergo a nucleophilic substitution reaction. That means this Br group will be substituted by CN, okay? Now, if CN undergo reduction, as I told you, lithium aluminum hydride is a very strong reducing agent. It will reduce this CN to CH3, CH2, CH2, NH2, amine. It will reduce this nitrile compound to amine. So that means A is this. Which is A? We have three options which matches it. Okay, done. B is 1, 2, 3, carbon 1, 2, 3, 1, 2. So this might be our correct answer. Okay, then C, HNO2 at 0 degrees Celsius. HNO2 is 0 degrees Celsius. We will get actually disonium salt. We will get a disonium salt, aliphatic disonium salt actually. CH2, N2 positive, Cl negative. But this is highly unstable. This is highly unstable. So if we have normally we'll have water molecule lying around or hydrolysis happens and this gets converted into alcohol. This gets converted into alcohol because this compound is highly unstable. Why? Because this is an aliphatic disonium salt, not aromatic. This is an aliphatic disonium salt. So this is your C. This is your C. So correct option is option A. How many of you answered A? Ilu, Anand answered A, Mohammed answered A, Heyman answered A. If we had AgCN, then it would have been RNC. Yes, correct. Yes, correct. Okay, living B and D, anyone? Living B and D, anyone option, ma'am? B and D. Yes, because we get NC here. Okay, and then the second step gets alcohol. How will we get alcohol? The first one is CN. We will get CN, not NC, not isocyanide. We'll get cyanide here. Okay, and then we reduce cyanide, we'll get amine, and then amine on treatment with nitrous acid. Amine on treatment with nitrous acid will get alcohol. Okay, because this is highly unstable, we get alcohol. One more thing, when aromatic amines are treated with nitrous acid, when aromatic amines are treated with nitrous acid, what we'll get? We'll get disonium salt. Again, when aromatic amines like aniline, if you treat aniline with nitrous acid, what we will get? We will get disonium salt, benzene disonium salt. Okay, right? But since this is unstable, this is an aliphatic disonium salt, this is unstable, that's why it decomposes and we get alcohol. Okay? Okay. Yes, BDC is incorrect. Are you saying that? Yes, BDC is incorrect. Okay. Let's move on to the next question. Aniline does not undergo which reaction? Aniline does not undergo which reaction? So aniline, what is aniline? This is aniline, right? Does it undergo nitration? Does it undergo nitration? Yes, it does undergo nitration. What are the major products? We'll get two major products. These are the two major products when aniline undergo nitration. When aniline undergo nitration. Okay? Okay. Friedel-Crafts, yes, Friedel-Crafts. Sulfonation, yes, it will go undergo sulfonation also. SO3H, NH2, SO3H. Bromination, yes, it does undergo bromination when treated with bromine and H2O. We'll get 2, 4, 6 substituted bromine, substituted aniline. Okay. Okay, yes, it will not undergo Friedel-Crafts reaction. Why? Because in Friedel-Crafts reaction, we use this reagent. In Friedel-Crafts reaction, what reagent we use? We use AlCl3. Now, see, AlCl3 is a Lewis acid. AlCl3 is a Lewis acid. That means it is a good electron acceptor. It is a good electron acceptor. And aniline is a Lewis base. Aniline is a Lewis base. That means it is a good electron donor. It is a good electron donor. Now acid-base reaction happens. Acid-base reaction happens and we get this compound. This salt actually, NH2 positive, AlCl3 negative. This compound, we will get this compound, this salt. Okay, now this compound is this group actually. This group is highly electron withdrawing group. Highly electron withdrawing group, right? And Friedel-Crafts reaction is an example of electrophilic substitution. It is an example of electrophilic substitution. That means an electrophile comes and attaches itself to the nucleophile. An electrophile comes and attaches itself to the nucleophile. Substitute an atom and attaches itself to the nucleophile. Okay, now see, this is electron withdrawing. This is already withdrawing the electron from the ring. Will the reaction happen? When an electrophile comes, this is also electrophile, right? Because the electron density is less because of this group, okay? The electron density is less because of this group. And when an electrophile comes, will the reaction happen? No, the reaction will not happen. So that's why it does not undergo Friedel-Crafts reaction. Because of this AlCl3, the catalyst that we use, AlCl3. Why are there only 12 people there? Why are there only 12 people there? Acid and base will react. C, correct. Oh, none of you is interested in this chapter, amines and biomolecules, huh? Is it so bad? Damn. C, yes, C. Okay. So, breakfast time. Okay. Breakfast time. Wow. Kani, in every class you have been here for so long. I remember your name. You don't remember mine. I'm not telling you my name. Even they don't like animes. Amines. Okay. Anime is different. So, amines, yes. No one likes amines. Okay. So, the quickly you answer, the quickly we'll wrap it up. It depends on you, right? The quickly you answer the questions, the quickly we'll wrap it up. Okay. No one likes amines. Okay. I prepared it for you. I was up all night and you guys are not liking it. No, it's okay. Okay. So answer the questions. We'll wrap it up early. Okay. Okay. In this reaction, this is the reaction. We need to figure out P, Q and R. We need to figure out P, Q and R. So reaction is simple. The quickly you answer actually. I think the quickly you answer, the quickly the session will end. Okay. I think it was easy for them. Oh, it's easy? Okay. So, when aniline is treated with a reagent, it gives disonium salt. Okay, that is very easy, right? N2 positive, Cl negative. Disonium salt, that means that will be NaNO2 in HCl. NaNO2 in HCl. So, concentrated dilute, it's normally dilute HCl. Which HCl? Dilute HCl. Okay. So, P is NaNO2 in dilute HCl. So, option A, B, A, C and D. Any one of these options can be there. Now, if this is treated with Q, it gets converted into N2 positive and BF4 negative. BF4 negative. So, that means what was there? HBF4. That means the reagent we used is HBF4. This product is formed when N2 positive disonium salt is treated with, yes, HBF4. Okay. A. Everyone is answering A, so less correct answer is A. And when this is treated with R, copper in NaNO3, which is copper in NaNO2 actually, okay, we will get a nitrobenzene. So this is the method of synthesizing nitrobenzene, converting aniline into nitrobenzene. So you guys are ready actually. Hamshika, C, why C? Macha, okay. So everyone A. Everyone answered A. Yes. So the correct answer is option A. Next question. See, if you answer quickly, the next question will come quickly. Okay. Time duration, Shravya, I don't know the time duration. I'm trying to cover it in a duration of around 2 hours, which will be like 1 hour is almost how many? Now we are only 40 minutes down. Okay. So possibly 1.15 minutes more. Okay, it depends on you actually. If you can answer the question, because biomolecule questions are straightforward, no much explanation there. Okay, for these questions you need something. Okay, you are answering A, you are answering some, answering D. Why D, bro? Okay, so in carbylamine test, primary amine, this test is for primary amines first of all, right? So when a primary amine is treated with chloroform, and in any alkali, in presence of any alkali, we will get RNC, which is a compound called isocyanide. This is a foul smelling compound. Okay? So this is a test used to distinguish primary amines. Only primary amines give this test. This test is called carbolamine test, and the product formed is option A. Akash, why D? Option A. Correct. So yes, all of you answered option A. Yes, see, done. Next question. Okay, this is the reaction C6H5CH2Cl. Okay, benzyl chloride. Okay. Yes, next question, Kani, answer it. Okay, so if C6H5CH2Cl, a benzyl chloride, is treated with ammonia, what we will get? This is ammonolysis, right? Ammonolysis of alkyl halides. Yes, what will be the name of product? Answering too quickly actually. Okay, so the product we get will be C6H5CH2NH2. Done? This is A. We are asked the name of product B. Now if this product A is treated with 2 molecules of CH3Cl, again Hoffman ammonolysis, right? A, right. So the product we will get is these 2 hydrogens will be replaced by CH3 group. These 2 hydrogens will be replaced by CH3 group. Okay. So what is the name of this compound? NN dimethyl. Phenyl is a substituent, and then this nitrogen is directly connected to this methane, right? So methane amine. So yes. Why? No, B. B is not the answer. A. Yes. Anand, Kani, Ilu, Muhammad, Akash. Okay, everyone answered A. So the name of this compound is NN-dimethyl phenyl methane amine. Okay, because this part is directly connected to amine. Okay. Yes. Oh my God, you guys are really fast actually. That's actually really nice. Okay, maybe your brain cells woke up now after having breakfast. Okay. Okay, let's move on to the next question. Okay, Macha. Okay, now let's see. There is a hydrocarbon C4H8. So we know for a fact that C4H8 means this is an alkene. What it is? It is an alkene, right? This alkene on reaction with HCl gives a compound C4H9Cl. Then it is treated with 1 mole of ammonia. Then obviously it will be something like ammonolysis, and we will get C4H11N. On reacting with NaNO2HCl followed by treatment with water, NaNO2HCl followed by treatment with water, we will get what? We will get an alcohol actually. Compound D. This is C, this is B, this is A. Okay. Now tell me what is the correct answer. Option doesn't clear. Oh, it's okay. You just solve, no. You solve it with me and then tell me the answer. Option are not clear. I'll try. Will it become visible? I will try to correct the answer actually. I hope it is clear. This is hydrogen. Okay. Let me give you a hint. In between option A and B is your correct answer. Option A and B is your in between these you will have correct answer. Okay. So let's see. Okay. So if C4H8 is an alkene, so we have 2 possibilities, right? Either it can be this alkene, butane to butene, or it could be but1ene, or this. Either of these alkene when treated with HCl, 50-50 chance. Okay, you're taking the risk. I told you already option A and B is the, okay, you're going with B. Don't take the risk, solve it, okay. So we have these two kind of alkenes. When we treat them with HCl, what happens? No peroxide is there. The addition will happen via Markovnikov rule. Markovnikov rule means the more substituted alkene, the more substituted carbon will get the Cl, okay. So in this case, here, and in this case, obviously here, both are equally substituted. So either way we are getting the same compound. Here will be single bond. Okay, either way we are getting the same compound. Okay, so this is A. Any of these can be A. Okay, B will be what? B is this. CH3, CH2, CH, Cl, CH3. This is B. Okay, now when this B is treated with NH3, what will happen? One hydrogen is replaced. We will get what? NH2. Primary amine, this primary amine, what is this? This is C. This is C, right? When this primary amine is treated with NaNO2 in HCl and then hydrolyzed, we get the product, right? What? Alcohol. We get alcohol. We get alcohol. Joe, you went with the correct answer. Okay. So Shavya also answered correctly. Darshan, correct. B. Hamshika, B. Start biomolecules. You'll sleep more in biomolecules, trust me. Okay. So the correct answer is option B, because what will happen? This NH2 group will be replaced by OH. Firstly with N2 positive Cl negative, and then after that water is there, right? So we will get an alcohol. This is the correct answer. CH3 CHOH CH2 CH3. CH3 CHOH CH2 CH3. Okay. Yes, I remember you, Akash. Start. Alcohols there in last steps, why? That's why B. Yes, B is alcohol, yes. And one more thing, is it optically active? Is it optically active? Yes, it is. Why? Because this carbon is a chiral carbon. This carbon is a chiral carbon. That means all the four atoms that the carbon is bonded to are different. All the four atoms are different. That's why it is a chiral carbon. And chiral carbon are normally optically active. Few other factors you need to consider, but here we are talking about optically active, so this is optically active. Okay. Yes. B. S. Why S? B. Yes, the correct answer is B. Next question. Is it visible to you all? Let me see. Again, simple reaction. We have nitrobenzene. It is treated with Br2 in presence of FeBr3. What will happen? Bromination at meta position, because NO2 group is meta directing. So here bromination will happen. This is your P, and then after that it is treated with tin in HCl. Again, this is a reducing agent. This is a reducing agent. I am telling you the reaction. It's okay. I can't do much about them. The lighting is really bad, I think. So when it is treated with tin HCl, this get reduced to what? This nitro compound will get reduced to aniline, NH2, and bromine will remain as it is. This is your Q. Q is treated with simple reaction. Q is treated with NaNO2 at around 273 Kelvin in presence of dilute HCl. That means firstly we'll get a disonium salt. N2 positive, Cl negative, and here will be Br. And final step, we treat it with warm water. So that means this N2 positive, Cl negative will get replaced by OH group. What we will get? We will get an alcohol. CCB. A. The correct answer is option A. So that means here we will have OH, here we will have bromine. Metabromophenol. This is NO2 positive, NO2Cl. This is NH2, this is NO2. Obviously, I think itna to visible is there, right? BROH, metabromophenol. That is option A. Yes. For these kind of questions, I can let you go, right? Because the screen is not visible for you all. How many A's? There are not many A's. So some of you answered C also. B is there also. Not visible. Sorry. I'll try. Please. Yeah, the next question is different. Hinsberg reagent. Which is Hinsberg reagent? Firstly, Hinsberg reagent. What is Hinsberg reagent? And what is this Hinsberg test? So, Hinsberg test is used to distinguish between primary, secondary and tertiary amines. So tertiary amines do not give this test, Hinsberg test, but primary and secondary amine gives Hinsberg test. Why? Because both these have acidic hydrogens. These have acidic hydrogens, while tertiary amines do not have acidic hydrogens. This you can answer actually. What is the Hinsberg reagent? Hinsberg reagent, yes, benzene sulfonyl chloride. Benzene sulfonyl chloride is Hinsberg reagent. Benzene sulfonyl chloride. This is Hinsberg reagent. Okay. So yes, in this you all are clear. Yes, correct. Option A. And every one of you there like this session. If you do not like this session, I'm not blackmailing actually, but if you do not like this session, obviously I don't want to come and teach you in that point, because you are studying there, I know that, but still liking is not that, doesn't take that much of your time, okay? And I do want to teach you further on, because I have like now I know your names, not faces actually, now I know your names, so I would want to come and teach you. So please like this session. It's like a motivation for us, you know, to wake up early and, you know, come to the class at 9. Okay. Hi Somu. Oh, okay. So let's move on to the next question. If aniline is treated with concentrated HNO3 and concentrated H2SO4, so these are the reagent of nitration. These are the reagents used for nitration. We get para-nitroaniline and meta-nitroaniline. So I told you, when aniline is treated with concentrated HNO3 and H2SO4, what do we get? We get meta-nitro, para-nitroaniline and meta-nitroaniline. So why do we get these? Are present in almost equal amount. Why do we get these compound? C, B, C, B, C, A, C. Meta-directing property of NH2 group? No, NH2 group is not meta-directing. It is ortho and para-directing. This group is ortho and para-directing. So that is not the reason. Incorrect. Protonation of NH2, which causes ortho deactivation of benzene ring. Yes, that is the reason. So what happens when you have concentrated HNO3 and H2SO4? It's a good oxidizing agent. You have oxygen. When oxygen is there, this NH2 gets protonated. This NH2 gets protonated and we get NH3 positive. Now this group, anilinium ion. This is anilinium ion. This anilinium ion is meta-directing. This anilinium ion is meta-directing, right? Meta-directing, and that's why we get a meta product. That's why we get a meta product. Okay, so the correct answer is option. How many of you answered B? B. Yes, the correct answer is option B. C and D are obviously meta-para-directing property NH2 incorrect. Isomerization, no isomerization is happening here. Yes, so in this case, Shravya, why C? Rest of you answered B. Correct, Akash? Okay, Hamshika, B, Hema, Shomu. Okay, B. Yes. Next question. The reaction of benzene disonium chloride with aniline yields yellow dye. What is the name of yellow dye? The name of the yellow dye. This is benzene disonium chloride, right? This is benzene disonium chloride. Sorry. When it is treated with aniline, in acidic medium, normally in acidic medium, we get a yellow dye. What is that yellow dye? What is the name of that yellow dye? A, B, 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 B. Yes. Heman A, Kani A, Shravya B, 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 14A. Mohammed, 14A is not correct. Nope. We will get this compound. I'll draw the compound. You just need to give me the name actually. I'll draw the compound. The compound form will be this one. What is the name of this compound? What is the name of this compound? A. One sec. C. Wow. Damn. You all answered all the options. A, B, C is there. This is para-amino. This is azo group, azo and benzene. Para-amino, benzene. Yes, para-amino, azo-benzene. Para-amino, okay. Azo, this group is azo and benzene. Para-amino, azo-benzene. Nalin, not A. Yes, B. Hemant, A, B. Manju B. Okay. Hamshika, Nisha, Ravi. Okay, Shomu, Preetam, Shravya, Ravi. What if it is orange dye? That depends on the medium. We used acidic medium, that's why yellow dye is coming. If you use basic medium, color of dye will be different. Okay, compound name is almost always same. Name will be same, depend on the condition you are getting. No, different compound will get, different compound, sorry. P, okay. Next question. Biologically active adrenaline and ephedrine, yes, used to increase, these hormones are used to increase the blood pressure of us. What does they contain? Your choice. What is my choice? They are primary amino, secondary amino. What kind of amino group is present in them? So I'll just draw the structure and you just tell me, is it primary or is it secondary? We have, okay, then one sec. This is adrenaline. And this is ephedrine. Okay. So tell me, primary or secondary? Now to I have cleared it. Primary or secondary? Wow, Nalin, correct. A, B, C, D. Yeah. Any one of these will be there. B, A. What is this? Primary or secondary? Primary or secondary, I mean. This and this. Secondary, correct. Yes, it is a secondary amino group. So, adrenaline and ephedrine have secondary amino group. Third question. I think this is the last or second last question. Following is more basic than aniline. Basic than aniline. Basic means it can donate its electrons, right? We have diphenylamine, triphenylamine. So diphenyl will be like this. And when we have triphenyl, it will be like this. 3 will be there. I am little bad at drawing, okay? Don't judge me, please. Okay. This is para-nitroaniline. Then we have para-nitroaniline. And benzylamine. So, let me see. Yes, most basic is D, correct. Why? Because it is a primary amine first of all. It is a primary amine. Second, the nitrogen is not directly connected to ring. In all these cases, not this one. In all these cases, nitrogen is directly connected to this benzene ring. Now, when it is connected to the benzene ring, there is a delocalization happen. These lone pairs are delocalized over the ring. They are delocalized over the ring. But here, no delocalization is there. No delocalization of these lone pairs. No delocalization. Thus, the electrons are available for donation. No delocalization means the electrons are available for donation. And electron donors are bases. Electron donors are bases. So that means benzylamine is the strongest base here. Okay. It is more basic than aniline. It is more basic than aniline. Yes. So all of you answered D, which is correct. Okay. Thank you. Okay. You guys are C. Good. Okay. I think I saw B. Gabriel thalamide synthesis is used in the preparation of primary amines from thalamide. Which of the following reagent is not used? Which of the following reagent is not used? Correct? Okay. So we definitely use KOH for first step. For first step we use KOH, right? Yes. What do we use? We use NaOH also for the last step. Sometimes for hydrolysis we use HCl. This is Hinsberg reagent. This is Hinsberg reagent. This we do not use. We do not use in Gabriel phthalimide synthesis. What? Hinsberg reagent. Yes, D, correct. See, we got through this. Yes, and you guys answered correctly actually, and so quickly, all of you. And yet you have not liked this session. Yes. Okay, so I think I have no choice. You guys know not liking this session. The bigger the answer, it is the right option. No, that's not correct, Joe. If you guys don't like this session, then in the next class you won't be seeing me. Either Shiny ma'am or the Aishwarya ma'am will be coming. Okay. Okay. D. Yes, D. So all of you answered D. Now let's start with our next chapter. So before going there, so I want you guys to know that there's a ABHYAS KCET test series which is there for you all. If you are preparing for KCET, then you need to attempt mock test, you need to solve the chapter wise PYQs. Everything is there in this ABHYAS KCET test series at a price of $9.99. Okay, so if you are interested, if you are looking for a test series which because KCET is coming so close to you all, right? 23, 24, right? So yes, if you are looking for an organized way of studying, that where you find all the chapter wise PYQs, you find all the mock tests there only, which are in the real exam format, okay, and full PCMB coverage for all these subjects. If you are looking, then ABHYAS KCET test series you should go for. Okay, it's around a price of $9.99, like 1,000 rupees. Okay, so yes, let's start with the next one, which is our biomolecules. Okay, now are you ready? Okay, are you ready? Please be ready. Yes, we are studying biomolecules. You like this session, but the number of likes and the people here are not equal. Okay, yes, so let's start. Okay, not ready. Ready? Finally. How many questions in biomolecules? So we'll wrap up before an hour. I think it's not that many questions. I think 15, 19, I don't know, it's like 15 to 20 something. Okay, ready? Let's see. Bam, we are starting biomolecules. And you like this session? Okay, please like this session actually. It should not be like said to you all, but yeah, if you are watching it, if you are understanding, if you are taking something away from it, you should like this session. That's the only thing. You're not paying me any money, Okay, liked it. Okay, done. Thank you. Okay, now see, first question. We have acetic anhydride, bromine water, hydroiodic acid, hydrogen cyanide. What is the purpose of all these? When these are treated with glucose, these reagents are treated with glucose, we get a product. And what is the structural prediction we get from them? What is the structural prediction we get from them? Okay, you answered really quickly. Bromine water, hydroiodic acid, hydrogen cyanide. So when when glucose is treated with acetic anhydride, what do we get to know? We get to know that it has 5 hydroxyl groups. 5 hydroxyl groups. 5 hydroxyl, because we will get pentaacetate, that means 5 hydroxyl groups are there. Okay, only that's why we get pentaacetate. When it is treated with bromine water, we get 1 carboxylic acid, 1 COH group. Okay, now bromine water is a very mild oxidizing agent, it oxidizes aldehydes. So bromine water means glucose has an aldehyde group. Okay, hydroiodic acid, when glucose is treated with HI, what do we get? We get N-hexane. N-hexane means all the carbon atoms are in a single chain. This means glucose has a straight chain of 6 carbon atoms. Hydrogen cyanide, when it is treated with hydrogen cyanide, what we get? Yes, all of you are answering A. That was actually quick. Yes, that is correct. HCN, hydrogen cyanide, that means it has a carbonyl group, because at the end we get this group CN and OH, and then we have CH2,4, and here we have CH2OH. Okay, when treated with HCN we get this group. Okay, I hope I Yep. Okay. So that denotes structure. What structural prediction we get? That glucose has a carbonyl group. Glucose has a carbonyl group. Yes, correct option is option A. In this you don't need much time actually. I think we'll be able to wrap up a little more early. See, the sequence is this: amino acid, hormone, vitamin, carbohydrate. First should be amino acid, second should be hormone, third should be vitamin, fourth should be carbohydrate. Okay. So tell me which is the correct sequence. Glutamine, yes, it is an amino acid. Insulin is a hormone. Aspartic acid is not vitamin. Aspartic acid is a amino acid. Aspartic acid is a amino acid. That means this is incorrect. Arginine, amino acid. Testosterone is hormone. Glutamic acid is glutamic acid. That is also an amino acid, not vitamin. It is an amino acid, not vitamin. Okay, aspartic acid, correct, amino acid. Insulin, hormone. Ascorbic acid is vitamin C. Ascorbic acid is vitamin C. And ramenose is also a carbohydrate. That means the correct answer is option number C. Poll is not there, Heyman. Sorry, today poll is not there. Option C. Some of you are answering D. C. Yes, correct. The correct answer is option C. Thiamine. Again, thiamine is a vitamin. Which vitamin? It is vitamin B1. It is not a amino acid. It is vitamin. Okay. Yes. Okay. So, next question on your screens. Which example of carbohydrate exhibit alpha linkage? Which have alpha glycosidic linkage? Both of these. Which have alpha glycosidic linkage? So, tell me, which will have alpha glycosidic linkage? A. Yes. Amylose and amylopectin, which are the constituent unit of starch, both have alpha. In amylose we have alpha 1,4 glycosidic linkage. And in amylopectin we have alpha 1,4 as well as 1,6 glycosidic linkage. Clear? Option A. Cellulose have beta glycosidic linkages. Similarly, glucose and fructose, they do not have any linkage because they are monosaccharides, single unit. Okay, we have single unit. Option A. Yes, option A is the correct answer. Maltose and lactose, in that also lactose have beta linkages. This have beta linkages. Okay, so obviously these are incorrect options. The correct answer is option A. So how many of you answered option A? Yes, so all of you answered option A. Good. Next question. Sucrose is dextrorotatory, but after hydrolysis, in the mixture show leave your rotation. Why? So firstly, you should know sucrose is made up of two units. Sucrose is made up of glucose, alpha D glucose, and plus beta D fructose. Okay, beta fructose actually. Alpha glucose and beta fructose. This part is dextrorotatory, this is dextrorotatory, and this part is levorotatory. Yes, correct me if I am wrong. Yes. So, sucrose is dextrorotatory, but after hydrolysis it becomes levorotatory. Why? Because after hydrolysis this breaks down into beta fructose and alpha glucose. This part is levorotatory, this part is dextrorotatory. The contribution of this part is much greater than the contribution of this part. Lever-rotation is much greater than the dextrorotation, and because of that reason, the mixture will show lever rotation. Because of that reason, yes, 92.5, correct Sagar, yes, 92.5. That is the lever rotation of fructose. So yes, the correct answer is D. Lever rotation of fructose is more than the dextrorotation of glucose. Yes, Sagar, minus 92.5. I was going to say where's the minus, but you wrote it right now. Yes, correct. Next question. C1-C4 glycosidic bond is not found in C1-C4. So it is found beta linkages, lactose it is found. In starch obviously C1-C4 alpha linkages are there. In maltose obviously, yeah, in maltose also C1-C4 linkages are there. But in sucrose we have C1 and C2. C1 of alpha glucose and C2 of beta fructose. These glycosidic linkages, C1 of alpha glucose, C2 of beta fructose. Yes, option A. Not option C, Shravi. The option is A. C1 to C4 glycosidic linkages, glycosidic bond is not found in. It is not found in sucrose because sucrose has C1 to C2 glycosidic bond. C1 to C2 glycosidic bond. Okay? Okay. A. Yes, A is the correct answer, not D. Okay. Next question. The two forms of D-glycopyranose are. Two forms of D-glycopyranose. So, glucopyranose. What is glucopyranose actually? I'll draw the structure, one sec. D-glucopyranose. So, we have, I'll draw the structure. You tell me what is the relation between them. You don't need to memorize it, just have an idea what we're talking about here. This is here and okay, now this is alpha form and this is beta form. Beta alpha glucose and this is beta glucose. See, alpha glucose because this OH group is below and beta glucose because this OH group is above. Okay, is lying above. Hi Nitya. So, some of you are answering A, B, C. Hey, not like that. A, B, C. Yes, the configuration, anomers. These are anomers. Anomers means the configuration, the isomers that have different configuration only on one carbon. That have different configuration on one carbon. On one carbon, that are anomers. So these are anomers: alpha glucose, beta glucose, glucopyranose. Obviously the name, this is called glucopyranose. Okay, that means you are talking about glucose, alpha form and beta form. Okay, they are anomers because they differ in the configuration on only one carbon, this carbon. Rest all the carbons have same configuration. Okay, so that is, yes, differ at only one carbon. Hi Harshita. So the correct answer is option B. Sam is answering D. Shanta, not D. It's B. Yes. Hi Nitya. Hi. Okay, correct Sagar. Okay. The correct answer is option B, which is anomers. Next question will be easy for you. Alpha D glucose and beta D glucose are what? We just did it. They are anomers. Alpha D glucose and alpha D glucose and beta D glucose are anomers. They are anomers. Okay. That is option D. Hi Shobha, hi Ajit, Abhishek, hi Hemant. So you guys woke up just now or something? The class has been going on for so long. Started at 9. Okay, D. Yes, correct answer is option D, which is anomers. Next question. The glycosidic linkage involved in linking the glucose unit in amylose part of starch. Amylose. So amylose have only one kind of linkages. Amylose have only one kind of linkages. It constitutes around 15 to 20% of starch. It constitutes around 15 to 20% of starch. Okay. And it is unbranched. What it is? It is unbranched. And it has carbon C1 to C4 alpha glycosidic linkages. Alpha glycosidic linkages. C1 to C4 alpha glycosidic linkages. Okay. Am I missing something? Oh yeah, it is water soluble also. Yes, it is water soluble. Amylopectin is not water soluble. Okay. Amylopectin is not water soluble. Yes, you guys are running late. We have done amines. We are on biomolecules now. Okay. Hi Tasmia. A or D. So you are confused in between A or D. Yes, it will be either A, it will be either B. But we have C1 to C4 alpha linkages. alpha linkages, okay, alpha linkages in amylose. In amylopectin we have both alpha C1 to C4 glycosidic linkages, alpha C1 to C6 glycosidic linkages, okay. This is amylose and that is amylopectin, okay. Option A, no, correct answer is option D. It has alpha linkages, not beta. It has alpha linkages, not beta linkages, okay. Alpha. Yes, the correct answer is option D. Okay. Now let's move on to the next question. The glycosidic linkage present in sucrose. See, only those three type of sugars are there, carbohydrates are there, that's being asked every year. So glycosidic linkage present in sucrose. Sucrose have C1 alpha, C1 alpha glucose and C2 beta fructose. C2 beta fructose linkage, okay. So C1 of alpha glucose and C2 of beta fructose. C1 of alpha glucose and C2 of beta fructose. Yes, A. C1 of alpha glucose and C2 of beta fructose. That is the glycosidic linkage that is present in sucrose. Okay. Next question. Option A. So all of you are answering option. Wow, we are half already. Yes, you are halfway done. Okay, done. Okay. Which of the following gives positive Fehling solution test? So Fehling solution test is given by which? Reducing sugars. Now which among the following is reducing sugar? Reducing sugar. Tell me which among the following is reducing sugar. Sucrose, it is not a reducing sugar. Sucrose is non-reducing sugar. Sucrose is non-reducing sugar. Glucose, yes, glucose is a reducing sugar. Glucose, yes, correct. Glucose is a reducing sugar. That's why it will give positive Fehling solution test. Positive Fehling test. Fats and proteins do not give Fehling test, okay? They are not reducing, non-reducing. They do not, no test, no reaction. They do not give Fehling test, okay? So the correct answer is option B. Okay. Correct. Next question. Glycogen is what? Glycogen, where is it found? Glycogen is found in animals, right? Animals, yeast, fungi, they have glycogen, okay? It is found in animals. It is stored in animal body. Is it a structural polysaccharide? No, it is a storage polysaccharide. It is a storage polysaccharide, okay? Is it structurally similar to amylopectin? Yes, it is similar to amylopectin. It is similar to amylopectin. Amylopectin is a constituent of starch. It is a major constituent of starch, around 80 to 85%. Okay, it is, glycogen is similar to amylopectin, but it is extensively branched. Glycogen is similar to amylopectin, but it is extensively branched. Yes. So how many of you are answering? Not D. It is very similar to amylopectin, but it is extensively branched. It is extensively branched. Once again, if you guys didn't do at least 50 likes in this video, in this live actually, yes, yeah, in the next class we'll be having a little trouble, okay? You guys like this session if you are understanding something, if you're taking something out of it, okay? You're solving the PYQs. How many questions you are able to answer correctly? Which I'm seeing most of you are able to answer them correctly, okay? I don't want to say again like this session. You should like it on your own, okay? Right? Okay, so in this case, is it a polymer of beta D glucose units? Is it a polymer of beta D glucose units? Actually, it's a polymer of, no, it's not a polymer of beta D glucose unit. Nope, it is not a polymer of beta D glucose unit. Why? Because it is a polymer of alpha D glucose unit. It is a polymer of alpha D glucose units. Okay. It is similar to amylopectin but extensively branched. Correct answer is option B. Not D. Not D. It is similar to amylopectin but it is extensively branched. Okay. Number of carbon is different. Okay. The chain length is different. Okay. Structure is similar to amylopectin. Yes. So the correct answer is option D. Option B. Option B. Not D. All of you are answering incorrectly. Indu answered correctly. Komal, Shanta, Sagar also answered correctly. Okay. Komal again. Ma'am. Okay, done. Why? See, so many less likes you have. At least, you know, the guys, jitne you guys are here, at least do that much like. Some of you are just watching, no, not liking this session. I'm not liking it either. Okay? I'm not liking it if you're not liking my session. One of the following is an essential amino acid. So we have how many essential amino acids? 10. We have 10 essential amino acids. So we have a trick. PVT, Tim, A, Hill. So we have around 10 amino acids. Phenylalanine, valine, thiophene, and then we have tryptophan, yes, thiophene, tryptophan, isoleucine, say we have methionine, and then we have arginine, histidine, leucine and lysine. Okay. Okay, so yes, which, no. Essential amino acid. I just told you. Do you see any C here? No, right? Cysteine is not there. S here, S is not. Serine is also not there. Tyrosine, we have 2 T's here, but one is tryptophan and the other is thionine. Thionine and tryptophan. You can remember it like this. PVT, Tim, A, Hill. PVT, Tim, A, Hill. P is phenylalanine. V is valine. T is threonine. T is tryptophan. I is isoleucine. Yes, I is isoleucine. M is methionine. A is arginine. HI is histidine. L is leucine. And the last L is lysine. These are your 10 amino acids, 10 essential amino acids. We have around 22, right? So among these, 10 amino acids are given here. Yes. You can remember it like this, okay? And here you can see isoleucine and here you can see isoleucine. So this is the correct answer. One of these is essential amino acid, which is isoleucine. Okay? Okay. Yes, now all of you are answering D. Correct. Next question. Which of the following is generally water insoluble? We have vitamin C, it is water soluble. But vitamin C is water soluble. Amylose, it is water soluble. We just did it. It is a component of starch that is water soluble. Amylopectin is water insoluble. Glycine amino acid, it is water soluble. Fibrous protein, it is a part of tertiary structure of proteins. Okay. What it is made up of? It is made up of beta pleated sheets. This is a secondary structure. Beta pleated sheets is a secondary structure of protein. Okay, it's a part of tertiary structure of protein made up of beta pleated sheets. Okay, it is made up of beta pleated sheets. Okay, yes, and is water insoluble. Which is water. What is water soluble? We have one different type of protein, right? Globular proteins. They are made up of what do you call them? Alpha helix structures. They are made up of alpha helix units. Okay, globular proteins, they are water soluble. This is water insoluble. Fibrous proteins are water insoluble. Fibrous protein, we have keratin and myosin. Okay. Okay, example here, yes, here we have protein keratin, right? That is fibrous protein. Okay, myosin is also there. Okay, and what kind of interactions we have here? That too, in fibrous protein we have hydrogen bonds and disulfide bonds. Okay, and because of that they are water insoluble. Disulfide bonds, hydrogen bonds and disulfide bonds in fibrous protein, because of that they are water insoluble. Okay. Keratin, collagen, yes, collagen is also an example of fibrous protein. Okay, Next question, vitamin and deficiency kind of, sorry, disease. If this vitamin is deficient in our body, what kind of disease we'll have? Okay, one we know, everybody knows actually. Yes, so all of you, let me just check the last question. I didn't see the answer. Yes, all of you answered A. Ayesha, why D? Everyone is answering A. Yes. Okay, sorry. Let's move on to this question. Okay, vitamin A deficiency will cause what? Night blindness. Vitamin A deficiency will cause night blindness. So we know first is 3. First is 3. Either option C or option D. Either option C or option D. Ayo Mohammed, why B? Yes, either option B or either option C or either option D. Okay. Next, vitamin D. Vitamin D causes, deficiency of vitamin D causes osteomalacia. What is this disease? Osteomalacia, whatever it is. So it's like a weakening of bones. Your bones become extremely fragile. You can break it, like they break very easily. Similar disease is in childs, which is rickets. That is also weakening of bones. Okay, so this is due to the deficiency of vitamin D. That's why you always go out in sun, take your vitamin D supplements on time. Okay, D. Yes, so let's see. 2 is 4. That means the correct answer is option D. Let's look here. Vitamin E deficiency will cause muscular weakness. Vitamin D deficiency will cause muscular weakness. Okay, and this vitamin E deficiency will cause chemistry weakness. So don't skip the classes. Vitamin K is used for blood clotting. Okay, so whenever we have extra amount of blood, okay, and it's not clotting properly, that means you have deficiency of vitamin K. Increased blood clotting time, actually. Increased blood clotting time. Okay, that is fourth answer is 2. Okay, D. Okay, rickets. Yes, rickets, correct. Everyone is here. Who are you talking to? Hello, Akash. Yes, I am here. Yes, the correct answer is option D. All of you answered option D. Good. Correct answer is option D. Okay, so don't have deficiency in your body. Okay, eat your food on time, have proper nutrients. Okay, if any supplement you need, take that supplement. I think you don't need it, you are very young now, but after your 20s, 25, you'll need the supplement. Okay, take care of your health. Even the exam is there, but physical health is much more important. If you're not physically fit, you won't be able to sit for, you won't be able to study, you won't be able to sit in the exam. Okay, so in the long run you need your body, so focus on that. Prioritize your physical health and mental health. Okay. Okay, so yes, no vitamin E deficiency if you're taking my class every day. Obviously no vitamin E deficiency, vitamin ekta. Okay, sorry for the bad joke. Okay, let's move on to the next question. The vitamin that helps in clotting of blood, which is that vitamin? April 6 is your JEE exam. How was your first attempt, Komal? How did your first attempt go? You gave the first attempt? Okay, so yes, correct. April 5 is yours. Sagar, your JEE exam is on April 5. You're also giving CET. 85 percentile. That is actually very good score. Not kidding. Was it your first attempt, Komal? Was it your first attempt, Komal? In your first attempt, if you scored 85 percentile, you have a chance of scoring really good rank in JEE. Yours is on 4th. Okay, damn. So all of you are really studious. That's actually very nice. Okay, yeah, make me proud actually. Give your exam really nicely, study for it, to revision properly. Okay, April is very close, almost 1 day to go. First attempt 85%. Yes, Komal, you should be very proud. That's actually a very nice percentage, because in the second attempt the marks will kind of get, you'll get more than your first attempt, because the first time you're sitting here, you are getting 85, 90. Damn, nice, good actually, good. Okay, so vitamin that helps in clotting of blood is, yes, vitamin K, not B2. Vitamin K is the vitamin that helps in clotting of blood. Okay, yes, the correct answer is option D. Yes, correct, Khushi. Shanta, Akshat, Sagar, K, yes, Nisha, D, correct, good. Next question. Thyroxine produced in the thyroid gland is an iodinated derivative of which amino acid? iodinated derivative of which amino acid? So it is an iodinated derivative of tyrosine. It is an iodinated derivative, means iodine is also there, right? That amino acid is tyrosine. That amino acid is tyrosine. Okay? Yes. Which is correct answer is option C. And all of you, my dear kids, answered correctly. Okay? Let's move on to the next question. Hypothyroidism is caused by the deficiency of what? Hypothyroidism is caused by the deficiency of what? So firstly, hypothyroidism is caused by because of the malfunctioning of thyroid gland. Hypo means you are getting lesser amount, right? Hyper means you are getting more amount of thyroid hormone, like more amount of that hormone is secreted from your body, okay? But if it is in less quantity, then it's called hypothyroidism, okay? Which is okay. So the correct answer is yes, the deficiency of thyroxine. The deficiency of thyroxine. Okay? Yes, correct. Shanta, not D, option B. Okay? You forgot? It's okay. You remember it now. Okay. Okay. So, yes, not C. Glucocorticoid. No. That's a different hormone. No. That doesn't cause the deficiency of hypothyroidism. That does not cause the deficiency of thyroid. Okay. Also, some pituitary issues might be there, but we are talking about major deficiency, that is deficiency of thyroxine. Thyroid. Yes. Okay. If any in your family have, take care of them. They will have some issues regarding their. They'll get tired very easily. They will have this in hypothyroidism or in hyperthyroidism. Both cases, okay? If you have hyper, then in that case your throat will get swollen all. If you have hypo, you'll be always tired, your weight will go up really soon, okay? Like really quickly, actually. It's very difficult for people like those to lose weight. The type of linkage present between nucleotides. What are nucleotides actually? Nucleotides. So nucleotides have They have three components. They have a pentose sugar, and a nitrogenous base, and so if these two components are there, it is a nucleoside. These two components are there, then it is a nucleoside. Nucleotide have one more component. Then nucleoside, okay? Nucleotide have phosphoric acid, PO4 3 negative. Nucleotides have phosphoric acid, and this phosphoric acid helps doing phosphodiester linkages, helps making phosphodiester linkages between C3 and C5 actually. C3 and C5 of pentose sugar. What kind of linkages? It helps form phosphodiester linkages between C3 and C5 of pentose sugar. C3 and C5 of pentose sugar. Phosphodiester linkages. Yes, Kamal, not C, B. Phosphodiester. The nucleotides have what kind of linkages? Phosphodiester linkages between C3 and C5 of pentose sugar. C3 and C5 of pentose sugar. Okay, Shanta, C. Seriously, no. No, Joe. D is not the correct answer for this. B. Shankar, Komal, Swapna, again, Shanta, Kamal answered incorrectly. Yeah, Kamal, that's correct answer. Yes, Shanta also answered C. Okay, so almost there, I think. Or we are done. Yes, we are done. So these are all the questions from amines and biomolecules that you should focus on, okay, because these are the most repeated PYQs. They have been asked once or more than one time. They have been asked for more than one times in a different language. So they just switch the language, rather than asking directly, they'll ask the indirect question, okay, like that, okay. Now, I want you guys to complete at least 50 likes, so complete that, okay, then we are ending the session, okay. And if you have any other doubt, also that for that time I'm staying for 2-3 minutes, I'll be staying, right? So if you have any doubts, please share your doubts. Yes, the game is over, okay. How many you answered correctly? I saw some of you answered kuch questions, some questions were there where everyone was answering incorrectly. Yes, so please complete the likes, okay, do 50 likes at least, yeah. Okay, I hope you enjoyed this session. You understood something from amines and biomolecules, even if it's theoretical, I know, even if it's factual, but something you might take away from this lecture. Okay, something that you think is important, that was, you know, taught in a better way. Okay. Okay, so I am waiting for you guys to complete at least 50 likes, then we'll end the session. Until then, if you have any other doubts, please do mention, please do ask me. This week we'll be doing PU1 chapters mostly, okay, because after that I think PU1 is starting. Hydrocarbons is next, I think. Okay, what kind of linkages does nucleoside have? Nucleoside have, one second, nucleoside, what kind of linkages do they have? In nucleoside, thank you so much. 100%. Okay, good. Good, Joe. Okay, one more like to go. Glycosidic, yes. In nucleosides, we have glycosidic linkages. In nucleotides, we have phosphodiester linkages. Okay. Hi, Bhagya. 50 likes done. Thank you. Okay, I think we can end the class now. And yes, whose route was it? Khushi, right? So in nucleoside we have glycosidic linkages. Okay. Okay, done. Thank you so much for the class, and everyone, please study. Do not waste your time. Okay. I know you have IPL going on. Watch that IPL. It's okay. But yeah, apart from that, focus on your studies. You have JEE exams. So many important exams coming on. JEE is coming. You have KCET. Then you have COMEDK. Right. So many exams are there. Okay. You guys take care and see you in the next class. Any doubt you have, you can mention them in the comment section. I will answer it out, don't worry. Okay, and it was a really fun session with you all. Thank you so much, everyone. Okay, bye everyone. Bye Joe, bye Sagar. Okay, okay Shanta, you're welcome. Welcome everyone. Okay, okay, take care. Thank you. Bye bye. See you in the next class.